So, how do you find the solution in a graph, right? So, let's talk about how do we find the solution in a graph. So, how to find the solution? How to find the solution? We're going to practice finding it in three ways. First is in a graph. So if I was to draw a graph, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Maybe I'll go down a few more, 16, 17, 18. Maybe I'll go down to 18, something like that. And then go over here like this. So if I was to draw a graph, let's see, this would be my x-axis. It would be 0, 1, 2, 3, 4, 5, 6. So we'll go to 7 here. And then going up the line, I would do 1, 2. It would start at 0, go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so when I'm drawing this graph, right, I'm actually going to draw a line for each of my, I'm going to draw a graph for each of my equations, right? So my first equation is y equals x plus 3. And my second equation is two x minus 1 equals y. This is the same thing. So when I graph these rules, right, there's two ways to do it. The way that I have showed you guys before is, right, we take the, we start with the number that's in the spot where b goes, and we know that's our y intercept. So this place here, in y equals x plus 3, this is going to start at 3. It's going to start right there on the y-axis. And then because this is 1x, right, it's going to go up by 1 every time. So when it goes, so you're going to have one rise and one run. So when you have a one run, when the next time it's going to go up 1. And then you'll have another point right there. And then the next time it's going to go up 1. And you'll have a point there. And then the next time it'll go up 1. And you'll have a point there. And the next time it's going to go up 1. And you'll have a point there. Now, I did not, I usually don't draw this, but I do want to just point out, right, there's a hidden 1 right there. I didn't draw this, but I do want to point out that these numbers, by the way, these points match all of our data points, or all of our possible solutions from up here. Remember that when we were saying before, when x is 0, right? 1 times 0 is 0 plus 3. Y is going to be 3. And, oops, actually I should do this the other way. When x is 0, y is going to be 3. And when x was 1, y was going to be 4. And when x was 2, y was going to be 5. And we have all of that information right here. It's the same set, 0 and 3, 1 and 4, 2 and 5. And then you can see 3 and 6, 4 and 7, 5 and 8. Let's just stick with those ones for now. 3 and 6, when x is 3, y is 6. When x is 4, y is 7. When x is 5, y is 8. So one thing that you'll notice about these points that I made is that this first one is 0.03. The next one is 0.14. Right? That's where x is 1 and y is 4. That's where x is 2 and y is 5. So these points match. Like that's what these points are. All of the points on my graph are solutions to my, they're possible solutions to my equation. So there's 4 and 7, and there is 5 and 8. Actually, I think this is going to prove soon that I actually need to draw my arrow here, 5 and 8. And then my other line is 2x minus 1. So I know that that is going to start at minus 1. So, oops, I didn't even draw my minus 1 on here. Minus 1 goes down here, negative 1. So my starting point for this one is going to be negative 1. And then as I go up, I know that it's increasing by 2 every time. So as this goes over 1, it's going to go up 2. So 1, 2. And then over 1 and up 2, 1, 2. 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 So when I draw this one, right, these points are all, I have points at the end of each of these arrows here. And I draw my line and connect all of them. And then, again, all of my points are going to match. Remember, we said that when x was 0, y would be negative 1. When x was 1, y would be 1. When x was 2, y would be 3. When x was 3, y would be 5. When x was 4, y would be 7. And when x was 5, y would be 9. Well, that is exactly what we have. We have x is 0, y is negative 1. That's that point. This point right here is when x is 1, y is 1. And this point is when x is 2, y is 3. And then when x is 3, y is 5. And when x is 4, y is 7. And when x is 5, y is 9. So again, we're just like our solutions, all of the points on our graph are just solutions to our equation. The graph line is just a literal list of all of the possible solutions to my equation. So anyways, as we were saying, the place where, as we showed before, our solution was at 4 and 7, right? That's what we saw up here. Our match, the place where they match is at 4 and 7, and 4 and 7. And when we look at the graph, we see that there's actually a very special place where we see that. We look at both points there right here at 4 and 7, and that is the point of intersection. This is called the point of intersection. And we can always tell it. It is where it's where the lines cross. And in this case, the lines cross at 4 and 7. And I can tell that they cross at 4 and 7 because this little dot right here lines up with 4 on the x. You know what? I made my dot a little bit low. It's actually supposed to be up there. And 7 on the y. So that is our solution, and we see that that matches our answers, right, from both of our number sets here.